In this video, we'll discuss the fundamental theorem of calculus part 2. Basically making the connection between antiderivatives and the definite integrals. And so let's try to do that. The assumption is always we have a function which is continuous. So continuous just means this function is integrable, right? So that's one of our fundamental results, which answers what kind of function is are integrable, right? So if you have a function is continuous, we want to evaluate integration from a to b, f of x dx, right? Suppose capital F of x, capital F is any antiderivative of f, right? I dot E f prime is f. Then you can use the antiderivative to evaluate this definite integral. So this is f of b minus f of a if this is true, right? A shortcut for that is f of x straight line, plug in b, plug in a, right? That means f of b minus f of a. So let's try to justify that. The justification, right? Why is it true? So for sure, this is implied by the part one of fundamental theorem of calculus, right? So we know that f here is an antiderivative of f. And remember, we have a function g of x equal integration from a to x f of t dt. This is also an derivative of f. So which means this function and this function, they share the same derivative. Their derivatives are both equal to f, right? They are the antiderivative of the same function. By our discussion before, if two functions share the same derivative, their difference is a constant. So we get g of x must be f of x plus a constant, right? So that's basically one application of one implication of mean value theorem, right? So let's try to calculate g of b minus g of a. By the definition, this is integration from a to b, f of t dt minus g of a integration from a to a, f of t dt. And the second term is 0 because lower bound equal to the upper bound. Integration from a to b, f of t dt, which is same as integration from a to b, f of x dx, right? Because as we mentioned, the variable name in an integral is a dummy variable, right? You can replace to anything you want. Now let's try to use another definition to look at g of b minus g of a, right? Use this equivalent equation here. This will be f of b plus c minus f of a plus c. Same constant, they cancel each other. So this is f of b minus f of a. So this shows this equal to that, which is same as this, which is equal to this. So these two are same. So this is basically the fundamental theorem of calculus part 2, right? So let's see one example. Let's see example, right? Let's see a quick example. We have integration from 1 to 2, 4 plus x squared over x to 4 dx, right? So by the fundamental theorem of calculus part 2, all you need to do is figure out one antiderivative of this function. by our discussion about antiderivative, we don't have any quotient rule or product rule. We just know how to handle power functions and some elementary functions and sum and difference, right? So this is same integration from 1 to 2, 4 over x to 4, change it to the function we can handle, right? So this is integration from 1 to 2, 4 times x to negative 4 plus x to negative 2 dx. So these two are power functions, and also that's a sum. We know the antiderivative. So this is 4 times 1 over negative 4 plus 1, x to negative 4 plus 1, right? Then plus 1 over negative 2 plus 1, x to negative 2 plus 1. Then you want to plug in 1 and 2, right? And so this is equal to 4 over negative 3. Plug in 2, you get 2 to negative 3 plus 1 over negative 1, which is negative 1. Negative 1 times 2 to negative 1. So that's what you get when you plug in 2, right? Then minus 4 over negative 3, then plus negative 1. Because if you plug in 1, 1 to negative 3 is 1. 1 to negative 1 is also 1. Right? So that's basically how do we evaluate a definite integral use antiderivative, right? They are so different. Definite integration is a special limit. Antiderivative is just the inverse of derivative. So fundamental theorem of calculus, making the connection between antiderivative and definite integrals, which is why this is the fundamental result in calculus, which allows you to evaluate definite integrals more with an easier way, right?